The second 2009 R.R. Hawkins Award goes to, for the first time in the history of these awards, an E-product, John Wiley & Sons, Wiley Interdisciplinary Reviews, or WIRES. Accepting the award for John Wiley & Sons, please welcome Sean Cooper. Well,
Sean Pigeon from John Wiley & Sons. Sean.
Thank you, John. Thank you, Dan. It's really a great honor to accept a share of the R.R. Hawkins Award on behalf of Wiley Blackwell. In bestowing the Hawkins Award on the Wiley Interdisciplinary Reviews, the WIRES for short, the judges have given a powerful vote for the importance of interdisciplinary thinking in academic research and the critical role of scholarly publishing in assisting this collaborative endeavor. Of course, there's nothing new about interdisciplinarity. Archimedes was an interdisciplinary sort of fellow. Whether or not he actually exclaimed "Eureka" when he stepped into the bathtub, his famous observation concerning the displacement of water by a submerged object remains central to the modern science of hydrostatics. He designed many remarkable contraptions, including the spiral pump that bears his name, sundry war machines and siege engines, and, reputedly, a method for focusing the sun's rays to set enemy ships on fire. In his spare time, he elucidated the essential principles of static mechanics, found a method to calculate the area under the arc of a parabola, gave a remarkably accurate approximation of pi, defined formulas for the volumes of surfaces of revolution, and devised an ingenious system for expressing very large numbers. Jumping forward 1800 years, we meet an equally prodigious philosopher, the Frenchman Blaise Pascal, who at the age of 16 established a central theorem of projective geometry. At 19, in an effort to ease his father's tax calculations, Pascal invented one of the world's first mechanical calculators. Over the next 10 years, he made essential contributions to the study of fluids and conducted famous experiments that confirmed the existence in nature of the vacuum. In his spare time, Pascal helped to lay the foundations of probability theory, thereby strongly influencing the development of modern economics and social science. Meanwhile, across the English Channel, the young Isaac Newton was beginning to polish his own well-rounded CV. Newton is famous for his seminal contributions to physics, mathematics, and astronomy, having laid the foundations of classical mechanics, elucidated the law of universal gravitation, offered a revolutionary new theory of light and color, and co-invented the differential and integral calculus. Remarkably, despite all of this, Newton wrote at greater length on biblical interpretation and alchemy than he did on science. Well, you catch my drift. The history of science is replete with polymathic talent. So what happened? Where are these vast intellects today? These philosophical giants astride the scholarly stage, these discoverers of the laws of the universe who are equally at home in a metallurgist's workshop or a theological debating chamber. Have human brains become smaller or lost some crucial kind of connectivity? This seems unlikely. What really happened was something called the Enlightenment, the first ripple of the great wave of knowledge and data that is now, in the 21st century, crashing all around us. In 2008, the global research community generated more than 1.5 million research articles, a stack of paper reaching 2 miles into the sky. That's a lot for a person to read every year. So what is the beleaguered scholar to do in the face of this information cascade? Fortunately, Since the 19th century, the Academy has provided a convenient solution in the shape of specialized departments and narrow fields of study. The student chooses to learn the language of physics, or that of chemistry, or that of economics. The fields grow walls and become silos. Researchers prosper by devoting their energies to learning more and more about less and less. But this in turn gives us something of a problem for the modern research enterprise. It is no secret that the solutions to many of the most interesting and the most pressing scientific challenges are to be found at the interfaces of the traditional disciplines. Advances in the field of nanomedicine, say, require close collaboration amongst biomedical engineers, physicists, chemists, and clinical scientists. A proper response to the challenge of climate change demands that Earth systems scientists coordinate their assumptions with those of economists, ecologists, and social scientists. To comprehend the human mind and the human brain, we need the insights of philosophers, linguists, and computer scientists in addition to those of psychologists and neuroscientists. This integrative approach to research is the essence of the WIRES publishing model. First, we identify those emerging areas of research that occupy the intersections of the circles. Then, we identify leaders in these research communities who are deeply committed to the interdisciplinary ethos, and empower them to commission review content that is not constrained by the traditional disciplinary boundaries. By establishing a hierarchy of article types, from advanced reviews and focus articles designed for established investigators, to overviews and opinion pieces for newer researchers and advanced students, we create entry points to this content for readers at differing levels of sophistication without compromising the quality and depth of the material. There are other innovations too. The WIRES are published serially and in online volumes and issues, making them eligible for journal-like abstracting and indexing as well as impact factors. Simultaneously, all new content is populated into a meticulously designed thematic outline of the field in question. In this way, the WIRES combine the high visibility of the review journal literature with the editorial structure, comprehensiveness, and authority that one typically associates with scholarly reference works. But if I may introduce another circular metaphor to complement my disconnected silos and interlocking circles, the proof of the pudding is in the eating. We knew we were onto something with the WIRES when we began surveying the research community and heard glowing recommendations from academics in disciplines as diverse as computational statistics and energy technology and developmental biology. We also started some conversations with learned societies and found that they too thought this was a good idea. We've launched 5 WIRES titles so far, with another 6 at least to follow. It hasn't been easy to make this happen. Those of you who work for large publishing companies will understand how difficult it is to do something different. Are they books or journals? I've been asked this question approximately 1,000 times. Oh, it's a hybrid model. Our systems can't handle hybrid models. Which subject area do they fit into? When will you start making money? I may not have all the answers just yet, but in the meantime, it's good to have some confirmation from the PSP community that we're doing something worthwhile. Thank you very much.
Well done. So that is our program for today. I want to thank everyone here. Before you go, I want to thank everyone here for being here, those who participated in our film and the other things that we did. Thank you so much for being good sports and your willingness to help us get this story out to the multitudes. We have a hospitality suite on the second floor of this hotel, the Massachusetts Room, and all of the certificates are going to be available there for the winners. So if you're a winner, you have an opportunity to have your photograph taken with Tom Allen Dan Hawkins, pick up these certificates, and we hope that you will do that.